friends, here is Mr. Ramesh Chandra and taking lecture on trigonometry. This lecture is specially designed for the student who are preparing for NTSC exams, and this is above CBSE level. So let's start learning about the topic. Trigonometric ratio for negative angles. Consider this as x-axis and this is y-axis. And if we have a point P over here, let's say this is a point P and this is the origin that we join with this point, and let's say coordinate of this point P be x comma y. So we will have this angle as theta and this length as x and this length is y. Now if we take image of this point with respect to the x-axis, then this image will lie again on the circle, as you can see here. So this angle will also be theta and this angle will be minus theta. And if this is the length x and this is y, so this must be minus y. Hence the coordinate of image must be x comma minus y. As you can see here, this length is equal to this length and these two triangles are same, so this angle must be equal to this angle, and the image of point P will lie on the circle. Now this is O origin and OP length must be is equal to under root of x square plus y square. By Pythagoras theorem you can say that this is square plus this square is equal to the OP length. This is right angle triangle, and since this is a length, hence this must be greater than 0. And as per the trigonometric ratio, sine theta is equal to perpendicular upon hypotenuse, that is y upon hypotenuse is OP length. And in the same way, if we consider the triangle OMI, sine of minus theta, sine of this angle must be the perpendicular, that is minus y upon the OI. And from here you can see that OP is equal to OI is equal to radius of the circle. This is the radius of the circle, as you can see here, radius of the circle. So what you can observe here, sine of minus theta is equal to minus of y upon OP, and OP and OI are same, that is the radius, hence this is minus y upon radius, and that is minus sine theta. So we get first result as sine of minus theta is equal to minus sine theta. So we have derived the first result, sine of minus theta as minus sine theta. Similarly, the reciprocal of sine is cos x. So the same result will apply for cosec of minus theta is equal to minus cosec theta. Now, what's the importance of this formula? Like we need to find the value of sine of minus 30 degree. We need to find the value of sine of minus 30 degree. Then we can directly apply this formula as minus of sine 30 degree. And we know the value of sine 30, that is half. So minus half. Hence sine of minus 30 degree is equal to minus half. Let's move on another trigonometric ratio, that is cos of theta. That is cos theta is base upon hypotenuse. So base is x upon hypotenuse is the radius. in the same way, cos of minus theta in triangle OIM, cos of minus theta is equal to x upon radius. You can see. So what are you observing from these two? That is, cos of minus theta is equal to cos theta. In the same way, in the reciprocal of cos, that is sec, hence we have another formula for sec as well. Sec of minus theta is equal to sec theta. Then we have tan theta as y upon x. Y upon x. In the same way, in triangle OMI, tan of minus theta is equal to minus y upon x. Minus y upon x. So from these two, you can observe tan of minus theta is equal to minus tan theta. In the same way, the reciprocal of tan is cot, hence cot of minus theta is equal to minus cot theta. So these are the another two trigonometric ratios for negative angle. Let's summarize all the trigonometric ratio for negative angle. First one is sine of minus theta is equal to minus sine theta. Second, cosec of minus theta is equal to minus cosec theta. Third one, tan of minus theta is equal to minus tan theta. Fourth one, cot of minus theta is equal to minus cot theta. And fifth one, cos of minus theta is equal to cos theta. And sixth one, sec of minus theta is equal to sec theta. So you can observe these are the only two trigonometric ratio where negative sign is not affecting its value. This means that cos of minus 60 degree is same as cos of 60 degree, and that is cos of 60 is half. If you need to find the value of tan of minus 30 degree, then you can apply the formula. Tan of minus theta is minus tan theta, hence this is minus tan 30 degree, and this is equal to minus of tan 30 is 1 upon root 3 minus 1 upon root 3. Let's move on the quadrants. There are 4 quadrants. This is first quadrant, this is second quadrant, and this is third quadrant, and this one is fourth quadrant. And in this case, if we think of x comma y, sign of the point x and y, then these must be plus and plus in nature. Both x and y must be positive in first quadrant, and in second quadrant x must be negative and y must be positive. In third quadrant, negative comma negative, and in the fourth quadrant x must be positive and y must be negative. How we are getting this plus minus sign? Since this is a number line, if you write numbers on, then this is 1 2 3, so these are the positive values, and here we have negative values, minus 1 minus 2 minus 3 and so on. At this place there is 1 2 3 4, and here we have minus 1 minus 2 minus 3 and so on. So now you can clearly observe that xy point in the first quadrant both must be positive, and in second quadrant x is negative and y is positive. In third quadrant x and y both are negative, and in fourth quadrant x is positive and y is negative. So these are the quadrants. Now let's have a circle as shown here and a point P over it. P is a general point x comma y. Now if we draw a line OP, that is making angle theta. So if P is in first quadrant, if P is in first quadrant, right, then the angle theta must lie between 0 and 90 degree. Second point, if P lies in second quadrant, let's say at this point, let's call this be Q, and at that time the angle must be another angle beta, let's say, and for Q, beta lie between 90 degree and 180 degree. Or you can say that if we move in second quadrant, then the theta must become greater than 90 degree and less than 180 degree. Now for P lies in third quadrant, and in that case theta must be greater than 180 degree and less than 270 degree. And fourth case for P in fourth quadrant, then theta must be greater than 270 degree and less than 360 degree. Now consider point P x comma y and make a right angle triangle like this O, and this is M point, and then OM must be x length and PM must be y length. Hence OP length must be under root of x square plus y square. And we know that under root of x square plus y square is always greater than 0 for all x comma y belongs to real. This is a sign of for all. Now if we think of sine theta, then sine theta must be perpendicular upon hypotenuse, y upon hypotenuse under root x square plus y square. So what are you observing here? This is positive and y is positive in first and second quadrant. So sine theta must be greater than 0 whenever y greater than 0. So this implies sine theta is positive. Sine theta is positive in the quadrant in which y is positive. So in first and second quadrant y is positive. Hence sine theta is positive in first and second quadrant. In the same way, the reciprocal of this is cosec theta will also be positive in first and second quadrant. This is the first one. Let's say another case of cos theta. Cos theta is equal to base upon hypotenuse x upon under root x square plus y square. Now cos theta is equal to x upon under root x square plus y square, and hence since under root x square plus y square is positive, hence cos theta must be positive in which x is positive, and x is positive in this case, positive x is this, hence cos theta is positive in first and fourth quadrant. This implies cos theta is positive in first and fourth quadrant. Similarly, the reciprocal of cos is sec theta, and that is also positive in first and fourth quadrant. This is second one. Let's have third case, that is tan theta equals perpendicular upon base, that is y upon x. Now you can see tan theta must be positive where y and x are of same sign. So you can observe this. In the first quadrant, x and y both are positive, and in third quadrant, x and y both are negative. So this is positive when both x and y are of same sign. So this implies in the same way cot theta is equal to x upon y. So you can say that tan theta and cot theta are positive in first and third quadrants. At the moment you have seen that sine theta and cosec theta are positive in first and second quadrant, cos theta and sec theta are positive in first and fourth quadrant, and tan theta, cot theta are positive in first and third quadrants. So let's summarize all these trigonometric ratio. In first quadrant, all trigonometric ratios are positive. All are positive. All the trigonometric ratios are positive. In second quadrant, only sine and cosec are positive and rest are negative in this case. And in third quadrant, tan and cot are positive and rest are negative in this quadrant. In the fourth quadrant, cos and sec are positive. What does it mean? Let's have an example like 120 degree. 120 degree is less than 180 degree and greater than 90 degree. So 120 lies in second quadrant. Hence, sine 120 degree must be positive. And if we talk of tan 120 degree, then this must be less than 0 since tan is negative in second quadrant. Now if we take any angle of third quadrant like 240, that is greater than 180 and less than 270, this means that this angle lie in third quadrant. Hence tan of 240 must be greater than 0. You can memorize this like all sine and cosec, that is sine, all students, tan, that is take, c, cos for coffee. So you can remember this by using all students take coffee. All means in first quadrant all trigonometric ratios are positive. Student means sine and cosec are positive in second quadrant. Take t means tan and cot are positive in third quadrant. Coffee for cos and sec. In fourth quadrant cos and sec are positive and rest are negative. Let's solve an example. Here we have sine theta is equal to minus 3 by 5, where theta lies in third quadrant. You can see sine is negative in third quadrant. So in third quadrant, we have a right angle triangle like this, and this is theta, this is 3, this is 5, and this must be 4, following Pythagoras theorem. So this is sine theta, then reciprocal of this is cosec theta must be minus 5 by 3. And since theta lie in third quadrant, so in third quadrant we have tan and cot as positive. Hence tan theta must be 3 by 4, and that is a positive 3 by 4, and cot theta is equal to reciprocal rate, that is 4 by 3, and the rest must be negative. Cos theta is equal to base upon hypotenuse. Since this is in third quadrant, so this must be negative, that is 4 by 5, and the reciprocal of this is sec theta is equal to minus 5 by 4. So you can apply the concept of quadrants like here we have used. So here we have trigonometric ratio for any angle, and this is the trick to memorize all the relations for complementary, supplementary angle and Let's say change about y-axis. What does this change about y-axis means? Let's say this is x-axis and this is y-axis. So y-axis is like 90-degree angle, and this change means this is 90 plus theta and this is 90 minus theta. Change about y-axis. This angle is 270 degree. So if we think of this, then this must be 270 plus theta and this is 270 minus theta. In the same way, this is a 90-degree angle. If we have angle like this, 360 plus 90, that is 0, 5, 450. So again, we can write this sign as 450 plus theta, and this is 450 minus theta. So these are the change about y-axis. So what does it mean? If we change about y-axis, then sine will convert into cos and cos will convert into sine. You need to remember, you need to change sine in cos and cos into sine. In the same way, tan will change into cot and cot will change into tan. In the same way, another one, cosec will change into sec and sec will change into cosec. So these trigonometric ratio will interchange or if we have formula related to y-axis, like sine of 90 plus theta. So what we need to do is we need to change sine into cos theta. We need to change sine into cos. So sine will change into cos. One more we need to think about the sine of the trigonometric ratio. Let's say we have the formula for sine of 90 plus theta. Then sine will change into cos theta. And sine is positive in second quadrant. 90 plus theta is in second quadrant, hence in second quadrant sine is positive, so we need to apply positive sign here. So sine 90 plus theta is equal to cos theta is the formula. Let's say tan of 90 plus theta. Now tan need to change in cot, so this will be cot theta, and 90 plus theta going in second quadrant, and in second quadrant 10 is negative, so we need to apply negative sign here. So 10 90 plus theta is minus cot theta. Let's have another example, tan of 270 plus theta. So 10 will change into cot theta, 10 will change into cot theta, and 270 plus theta moving in fourth quadrant, and in fourth quadrant 10 is negative, so you need to apply negative sign here. Let's have another example, sec of 270 plus theta. Then sec will change into cosec theta, and 270 plus theta is in fourth quadrant, and in fourth quadrant cos and sec are positive, so we need to apply positive sign here. Let's say cot of 270 minus theta, then cot will change into tan, hence we will have tan theta, and 270 minus theta lie in third quadrant, and in third quadrant cot is positive, so we need to apply positive sign here. Hope you understand the case and the changes about y-axis. Let's learn the changes about x-axis. So this is x-axis, y-axis. and this is angle 0 or 360 degree. We can have 360 if we rotate one complete circle. Then this is 360 plus theta, and this is 360 minus theta, and this angle is 180 degree. So this angle is 180 plus theta is moving third quadrant. This is 180 minus theta is in second quadrant. Even you can have more angle as well, since this is 180, and if you complete one circle and one half circle, then you will have 360 plus 180, that is 540 degree. So again, if you need to have more angle as well, so this is 540 plus theta, and this is 540 minus theta. If we have change about x-axis, then there will be no change in trigonometric ratio, like sine will remain into sine, no change, cos will remain into cos, and tan will remain into tan. So means the whatever trigonometric ratio you have, this will be the same. So we have no change in trigonometric ratios. So like we have a sine of 180 minus theta. So since this is change about x-axis, so sine will remain into sine theta. Sine theta. Now we need to take care of sine plus or minus. Since 180 minus theta is in second quadrant, lies in second quadrant, hence the sign of this will be positive, as sine is positive in second quadrant. Let's say tan of 180 minus theta, again 180 minus theta lies in second quadrant, so this will be tan of theta. 180 minus theta lies in second quadrant, and tan is negative in this quadrant, so this is minus of tan theta. Now let's say sec of 360 minus theta, so sec will remain sec theta, and 360 minus theta is in fourth quadrant, and in fourth quadrant sec is positive, cos and sec are positive, so this is positive sign. Let's solve a problem related to the concept cos 90 plus theta. This is change about y-axis, so cos will change into sine, so this is sine theta, and in second quadrant cos is negative, so we need to apply minus sign here. Next, sec of minus theta is sec theta. As you can see, sec and cos have no effect, so sec theta. Tan 180 minus theta, this is change about x-axis, so there will not be any change, and this is in second quadrant, and tan is negative in second quadrant, so this is minus tan theta upon sec 360 minus theta. 360 minus theta is change about x-axis, and 360 minus theta lies in fourth quadrant, and in fourth quadrant sec is positive, so change about x-axis means there is no change in ratio, so this must be sec theta, and in fourth quadrant sec is positive, so we will have positive sign here. Now sine 180 plus theta, this change about x-axis, so sine will remain sine theta, but 180 plus theta lies in third quadrant, so sine must be negative, so minus sign here. Now cot 90 minus theta is tan theta. This change about y-axis, so cot will change into tan, and in the first quadrant all trigonometric ratios are positive, so this is positive sign. Now we can cancel them. Sec theta will cancel by sec theta, and minus sine theta you can cancel by minus sine theta, and here you can observe the minus 1 is the answer to this question. Here we have some important results. Sine n pi plus minus 1 to the power n theta is equal to sine theta for all n belongs to integer, where n are the integral value. You need to memorize this formula. And cos 2n pi plus minus theta equal to cos theta for all n belongs to integer, and tan n pi plus theta is equal to tan theta for all n belongs to integer. Let's understand this formula. Now for n is equal to 1, formula become sine pi, so minus 1 to power 1 is minus theta is equal to sine theta. So this is true. Pi is 180, so 180 minus theta goes into second quadrant, so sine of 180 minus theta is sine theta. This is true. Now for n is equal to 2, the formula become sine 2 pi and minus 1 to the power 2 is 1 plus theta is equal to sine theta. You can see 2 pi is 360 degree. So 360 degree plus theta is moving in first quadrant, and this is change about x-axis. So sine 2 pi plus theta must be sine theta. Now if we need to think for this formula, let's say for this formula, for n is equal to 1, cos of 2n pi, that is 2 pi plus minus theta is equal to cos theta. So 2 pi is 360 plus theta or 360 minus theta. For plus theta, the angle will move on first quadrant, and for negative 2 pi minus theta will move on fourth quadrant, and in both quadrant cos are positive, hence this is cos theta. In the same way for this, for n is equal to 3, let's tan 3 pi plus theta is equal to tan theta. 3 pi means 540 degree. 540 means this 540 plus theta means this is moving in third quadrant, and in third quadrant tan is positive. So you need to remember this formula, and this will help you a lot. So these are the general formula you need to remember. So this is the exercise number 5 related to the concept that we have learned today, and here are the answer key for these 5 questions.